what is the smallest integer b greater than 3 for which the base b 2, 3 base b is a perfect square? You don't need to specify this. If I write a number 2, 3 in a base system b, if a base system k is there, then the digits will be from 0 to k minus 1. Then the digits will be from 0 to k minus 1. So, if the digits that are used are 2 and 3, definitely b will be greater than or equivalent to 4. Because if I take base system 3, digit 3 will not be there. Digit 3 will not be there. In a base system 2, digit 2 will not be there. 2, 3 base system b greater than or equivalent to 4. After solving this question, I will go back to addition of 2 bases. Then I will explain, Namrata, why I did only for hundreds place. I thought by this time you should have understood it on your own. In case if you are not understanding it, I will do it. That comes under the type addition of 2 numbers. 2, 3 base system b, it is a perfect square. So, 2, 3 base system b, it is a perfect square. So, what are the perfect square? 1 square 1, 2 square 4, 3 square 9, 4 square 16, 5 square 25, 6 square 36 and so on. So, we are interested in finding the smallest integer. So, this is nothing but b power 0 and it is b power 1. So, 2b plus 3, it should be a perfect square. If I take 1, so b is nothing but 1. B has to be greater than or equivalent to 4. So, b cannot be 1. First of all, 2b plus 3. 2b, any number multiplied by 2, it is an even number. 3 is an odd number. Even plus odd number. 2b plus 3. Any number multiplied by 2, it is an even number. 3 is an odd number. Even plus odd number, it is an odd number. Answer has to be an odd number. 4 is not possible. Next case, 2b plus 3 is 9. So, this will become 2b equivalent to 6. B equivalent to 3. But the condition that is there on a base is greater than or equivalent to 4. So, it cannot be 9. 2b plus 3, it is an odd number. It cannot be 16. So, 2b plus 3 is 25, which will give you 2b 22. If 2b is 22, b is 11. If b is 11, 2 into 11 plus 3, 22 plus 3, which is 25. 25 is a perfect square. So, answer for this question is, write down the concept. Extremely important concept. I want each and everybody to pay an utmost attention to this concept. If you understand this concept, you don't need to find out the addition of 2 numbers in non-decimal, right, multiplication or anything. Just listen to this concept. There is a some random 3-digit number XYZ. XYZ is in base system 10. I am converting these right, XYZ in base system 10. Now see here, Z is there in units place, 10 power 0. Y is there in 10 power 1. X is there in 10 square. So, these are nothing but 100x plus 10y plus Z. I hope it is clear. 10 power 0, 10 power 1, 10 power 2. These are nothing but 99x plus 9y plus x plus y plus z. X plus y plus z. That means if xyz base 10 is there, these are nothing but 99x plus 9y plus x plus y plus z. Are you with me? If this number is divisible by 9, if the left hand side is divisible by 9, this is divisible by 9, 99 is divisible by 9, this is divisible by 9, x plus y plus z should be divisible by 9. What are x, y, z? X, y and z are the digits in that number. What is x plus y plus z? X plus y plus z is nothing but the sum of the digits Sum of the digits. If this is divisible by 9, this is divisible by 9, this is divisible by 9, x plus y plus z should also be divisible by 9. That is exactly why the divisibility rule of 9 is sum of the digits should be divisible by 9. Why in 9 sum of the digits should be divisible by 9? Why? Because if this left hand side is divisible by 9, 99 is divisible by 9, 9y is divisible by 9, definitely this should also be divisible by 9. Sum of the digits should be divisible by 9. Are you with me? Right. Now, example. Listen carefully to this example. 12 into 13 equivalent to 156. 12 into 13 equivalent to 156. I will apply both the sides, I will divide by 9. 12 into 13 by 9, right, equivalent to 156 by 9. Both the sides divided by 9. Both the sides apply remainder. Both the sides apply remainder. 9 when divided by 12. 9 ones are 9. Remainder is 3. 13 when divided by 9. 9 ones are 9. Remainder is 4. When you divide a number by 9, you will not get the remainder greater than 9. Further divide it. 12 divided by 9. 9 ones are 9. Remainder is 3. It should be there with the right hand side. 9 ones are 9. 66. 9 sevens are 63. 3 equivalent to 3. That is why digital sum is working to cross check whether the answer is right or wrong. 1 plus 2 is 3. 1 plus 3 is 4. 3 fours are 12. 1 plus 2, 3. These also 6 plus 5, 11. 11 plus 1, 12. 12 digital sum is 3. That is the reason digital sum will work for any of the mathematical operations. This is the proof why digital sum will work. Right? I hope it is clear. So, now I am not interested in teaching you what you already know. For me, there is an important observation. Once you have understand this observation, then your job becomes easier. I took in decimal system, let me take in base system 5. If I take in base system 5, these 5 power 0, these 5 power 1 and it is 5 power 2. 5 square into x is 25x, 5 into y is 5y, 1 into z is z. 25x plus 5y plus z. Can I write it like this? 24. Now you will understand, Manju. Please listen carefully. 24x plus 4y plus x plus y plus z. There also I wrote it like this. 100x is 99x plus x. Now it should be. If xyz base 5 is divisible by 4, if this is divisible by 4, 24 is divisible by 4, 4 is divisible by 4, x plus y plus z should be divisible by 4. X plus y plus z should be divisible by 4. 24 is divisible by 4, 4 is divisible by 4. X plus y plus z should be divisible by 4. What is the best conclusion from these two examples? In a base system 10, digital sum is divided by 9. In a base system 5, digital sum is divided by 4. Are you all with me? In a base system k, you can apply digital sum when you divide by k minus 1. In any base system, digital sum can be used if you know this concept. In a base system 10, I got x plus y plus z divisible by 9. In a base system 5, x plus y plus z should be divisible by 4. So, based upon these two examples, let me write down an extremely important concept. Concept is, in any base system k, you take any base system, digital sum is divided by k minus 1. Digital sum is divide by k minus 1. Extremely important concept. Digital sum is divide by k minus 1. It will work in any base system. In any base system is digital sum. Digital sum is sum of the digits. Sum of the digits should be divisible by k minus 1. With 2 1 in base system 6 plus 1 4 in base system 6. Generally how we will do? 1 plus 4 is 5. 2 plus 1 is 3. As long as the answer is less than the base, write it as it is. 1 plus 4 5, 2 plus 1 3. It is 3 5 in base system 6. This is one way. But I am not interested in telling you this. I am interested in dealing with another important point. In a base system 6, digital sum is divide by 5. Rambabu, team is, somebody is telling that my voice is low. Is it right? In a base system. Right. Now see here. In a base system 6, digital sum is divide by 5. Digital sum is divide by 5. 1 plus 4, 5. It is perfectly divisible by 5. 2 plus 1 is 3. Answer also it should be 3. 5 is perfectly divisible by 5. 3 and 3 both are matching. Therefore, it is the right answer. If the digital sum is not matching, then there is a problem in our calculations. Somewhere we did a mistake. Again, I am explaining. If you get a base system 6, digital sum is divide by 5. Wherever 5 is there, eliminated. 1 plus 4, 5 gone. Here also 5 gone. 3 and 3 it should match. I will take as many examples as possible. Another example. See here, one is a traditional method and another is optimal method. Method 1. Listen carefully to every key point. After the class is over, this class will not be visible again for further watching. Right? 4 3 in base system 5 plus 1 2 4 in base system 5. 1 2 4 in base system 5. Traditional method. How? Everybody will solve. 3 plus 4 is 7. 7 in base system 5. 5 ones are 5. 2 is the remainder. Write down the remainder here. 2. 1 carried. 4 plus 1 5. 5 plus 2 7. 5 ones are 5. Remainder is 2. Here it is 2. 1 carried. 1 plus 1 is 2. 2 base 5. This is the answer. Again I am explaining, listen carefully. 3 plus 4 is 7. 7 in base system 5 is 1 2. So 2 is written, 1 carried. 4 plus 2 6. 6 plus 1 7. 7 in base system 5 is again 1 2. 2 is written, 1 carried. 1 plus 1 is 2. Answer is 222. Now method 2. Method 2. Anil Nair's way. Method 2. Anil Nair's way. How I will solve this question is, if options are there, 4 3 base 5 plus 1 2 4 base 5. In a base system 5, what should we divide? We should divide by 4. Delete the digits 4 or whose sum is 4. Delete the digit 4 or whose sum is 4. 3. 1 plus 2 is 3. What is 3 plus 3? 3 plus 3 is 6. 6. Answer is 222. 222 in base system 5. 2 plus 2 plus 2 is 6. This is the matching answer. If options are like this, 222, 212, 232, 242. C and D. You don't need to do anything of this. Calculations are not at all needed. Again I am explaining. In a base system 5, digital sum is divided by 4. So 4 eliminated. 4 eliminated. 1 plus 2 is 3. 3 plus 3 is 6. Answer digital sum should be 6. It is 6. So directly answer digital sum should be 6. Just by looking at the question itself, you can get the answer. Idea clear, right? Method 1 and method 2. We will do some more examples. Second example. 623 in base system 8 plus 164 in base system 8. You please don't do it in a traditional method and try to solve it. Now we will do the Anil Nair's way of solving and check whether the answer is matching or not. Anil Nair's way of adding two non-decimal bases. 6 plus 623 base 8 plus 164 base 8. In a base system 8, digital sum is divide by 7. In a base system 8, right? In a base system 8, digital sum is divide by 7. 6 plus 2 is 8. 8 plus 3 is 11. 11 divided by 7. 11 divided by 7. 7 ones are 7. Remainder is 4. So, digital sum is right. I hope it is clear. 1 plus 6 is 7. Cancelled out. Remaining is also 4. Are you all with me, right, sir? So, 6 plus 2, 8. 8 plus 3, 11. 11 if I divide by 7. 11 if I divide by 7. Remainder is 4. 4 plus 4 is 8. Answer digital sum in the answer. 4 plus 4 is 8. 8 divided by 8. Either it should be 8 or 0. 8 or 0. Right? Now we will see. 3 plus 4 is 7. 7 is less than 8. Write down as it is. 6 plus 2 is 8. 8 divided by 8. 1, 0. 0, 1. 6 plus 1 is 7. 7 plus 1 is 8. 8 in base system 8 is 1007. I hope it is clear, right? 3 plus 4 is 7. It is clear. 6 plus 2 is 8. 8 is 1, 0. 0 and 1. 6 plus 1, it is 7. 7 plus 1, 8. 8 is nothing but 1, 0. 1, 0, 0, 7. Now if you see here, 1 plus 6 is 7. 7 is out. Digital sum is 4. 6 plus 2 is 8. 8 plus 3 is 11. 11. 11 digital. Here also it is 7 out. So here it is 1. So if you take here 3 plus 2, 5. 5 plus 6, 11. 11 digital sum. 11 when you divide by 7. 7 ones are 7. Remainder is 4. Here you are getting 4. 4 plus 4, sorry, here we have to divide by 7. 8 by 7 remaining is 4. Because in 8, digital sum is you should divide by 7. 4 plus 4 is 8. 8 when divided by 7. 8 when divided by 7. Answer remaining is 1. 1 and 1 both are matching. 1 and 1 both are matching. I hope it is clear, right? Both will definitely match. Because the digital sum is the best concept and it is the proven concept. If something is not working, that means you did a mistake. There cannot be any fallacies or an exception to this golden theory of mathematics. I hope it is clear, right? Here I did 0, it is 1. Why? Because 4 plus 4 is 8. 8 when divided by 7, remainder 1. 1 will match. One more. I think Madhavi wrote something and erased it. Maybe she has realized it. Next, 1A7. I think right now you can do the same thing. 1A7 in base system 16 plus 2B7A. 2B7A in base system 16. When you add it, what will happen? We all know that A is 1, 0. B is 1, 1. C is 1, 2, D is 1, 3, E is 1, 4 and D, F is 1, 5. A is 1, 0. 7 plus 10 is 16. 7 plus 10 is 17. 17 divided by 16. 16 ones are 16, 1, 1. Here 1. Here 1 carried. 7 plus 1 is 8. 8 plus A, 10. It is 18. 18 is 1, 2, 16, 1, 2. Write down 2 here. 1 carried. B is 1, 1. plus 2 is D here. Remaining value is 2D. Okay, B plus 2. B plus 2, how much it will become? B is 1, 1, 1, 2, 1, 3. Do T, T1. You don't need to do all this. What you will do? You will divide by 15 and check whether the digital sum is matching or not. I hope it is clear, right? Digital sum will help you to eliminate all incorrect answer options. In case if you got more than one correct answer, anyway this addition approach is always there with you. I hope it is clear. Instead of doing this, divide by 15 and you do it. How you do? What is A value? 1, 0. 1, 0 plus 7, 1, 17, 17 plus 1, 18, 18 divided by 15, remainder 3. Next one, A is 1, 0, 1, 0 plus 7, 17, plus 2, plus 1, 1, 11 plus 2, 13, 13 plus 17, 30, 30 divided by 15, remainder 0, 3 plus 0, it is 3, T plus 3, 0, it is 3. Now you will easily get D is 1, 3. 1, 3 plus 2, 15. 2 plus 1 is 3. 3, 3 answer is matching. 3, 3 answer is matching. Very easy if you understand these concepts. Extremely easy. Now see here. Difference. How the digital sum will work for difference. How the digital sum will work for difference. For every concept, there are some better approaches. If you do not know, then probably you do not have access to great teacher. Does not mean that whatever you know is the best method. How will digital sum work for difference? First, we will do with an example in decimal system. In decimal system, we will take an example. Same concept in decimal system. 67 in base system 10 minus 39 in base system 10. 67 minus 39 is 28 in base system 10. 67 minus 39 is 28. How will you check by using digital sum? How will you check by using digital sum? 6 plus 7 is 13. 13 is 1 plus 3, 4. Are you with me? 6 plus 7 is 13. 13 divided by 9, remainder is 4. Minus 3 plus 9 is 12. 12 divided by 9. 9 ones are 9. What is the remainder? 3. 4 minus 3 is 1. Answer digital sum should be 1. 2 plus 8 is 10. 10 divided by 9. If I divide 10 by 9, what is the remainder? 1. Digital sum will also work for difference. Not only digital sum works for addition, subtraction, multiplication, division, everywhere it will work. Right? With this understanding, let us solve the previous question. What is working for decimal system should definitely work for any of the non-decimal system. There is no difference in any of the concepts. There is no difference. I hope it is clear. Right? Now, let us solve this question. Express the difference 25 base 7 minus 12 base 7. 25 base 7 minus 12 base 7. 25 minus 12 is 13. 13 base 7 is the answer. 25 minus 12 is 13. This is one way to look at it. I don't want you to get the answer and feel happy that I got the answer. My entire approach revolves around telling the hidden concept behind the most so-called obvious thing. If I use by using a digital sum, what is the entire idea? Entire idea is if I get a base system K, digital sum is divided by K minus 1. Digital sum is divided by K minus 1. Digital sum is divided by K minus 1. Now see here. 2 plus 7 is 5 is 7. 7 divided by 6. 6 ones are 6. Remainder is 1. Minus 1 plus 2 is 3. Minus 3. 1 minus 3 is minus 2. Minus 2. Suppose 10 divided by 6. Positive remainder is 6 ones are 6. Positive remainder is 4. Negative remainder is 6 twos are 12. Negative remainder is minus 2. If you get a negative remainder, add it with the number you are dividing and make it positive. You got minus 2. If you got minus 2, add it with 6. 6 minus 2 is 4. 4 and 4 both are matching. 4 and 4 both are matching. Are you all with me? In case when you are getting a negative remainder, add with the denominator that you are dividing. I am dividing everything by 6. Why am I dividing everything by 6? Because in a base system K, digital sum is divided by K minus 1. In a base system K, digital sum is divided by K minus 1. Because in the question it is given, base system 7, digital sum is divided by 6. I hope you got the idea. Very elementary question where you can attack by using the answer option. Now see here. Another question. 537 base system 9 minus 216 base system 9. We will see the answer little later, which is method 1. I don't want you to solve it in a traditional way. I want you to solve it in a very logical, fastest way. Anil Nair's way of solving the second thing. 537 in base system 9 minus 216 in base system 9. In base system 9, what is the divisibility rule? Divide it by 8. 5 plus 3, 8 cancel. 6 plus 2, 8 cancel. 7 minus 1 is 6. Answer digital sum should be 6. Answer digital sum should be 6. Check with the answer option where the digital sum is 6. Let us see. 7 minus 6 is 1. Generic subtraction. There is no borrow. 3 minus 1 is 2. Generic subtraction. No borrow. 5 minus 2 is 3. Generic subtraction. No borrow. What is 3 plus 2? 5. 5 plus 1, 6. It is matching with the digital sum 6. Are you all with me? 514 base 6 minus 433 base 6. Now see here. Method 1, method 2. Method 1 is the traditional subtraction. Another is, every question if you observe I am using a concept to make you solve the question in less time. Digital sum or Anil Nair's way of solving the question. How you should solve it? It is 6. Digital sum is 5. All are cancelled. So it is 0. It is 6. 4 plus 3, 7. 7 plus 3, 10. 10 is divisible by 5. It is also 0. 0 minus 0 is 0. 0 means answer digital sum should be 5. Because only when 5 is divided by 5, remainder will be 0. 5 is divided by 5, remainder is 0. Now let us solve. 4 minus 3 is 1, generic subtraction. 1 will not go in 3. I will take carry 1. 1 will become 6 carry. 6 plus 1. 6 plus. Suppose you are doing 32 minus 19. 2 will not go in carry. 1 carried. 10 plus 2, 12. 12 minus 9, 3. Similarly, 1 carried. 1 in a base system 6 is 6. 6 plus 1, 7. 7 minus 3, 4. 5, 1 is taken out, remaining 4. 4 minus 4, 0. See here, finish. 4 plus 1 is 5. 5 when divided by 5 is remainder 0. Just by looking at a question, this is a traditional method. Traditional method. Answer is the digital sum approach. I want each and every student who is watching the class, in spite of doing an unproductive work, to kindly reply it in the live chat if it is clear to you. If it is clear to you, I want you to reply in the live chat if it is clear to you. How the digital sums, beautiful concepts are being used in non-decimal addition, non-decimal subtraction. 514 in base system 6, 433 in base system 6, 4 minus 3, 1. 1 will not go in 3, 6 carried, 6 plus 1, 7, 7 minus 3, 4, 5, 1 carried, 1 became 6, 4 minus 4 is 0.